Hello everyone, my name is Nikola Hlavsa. Today I will be presenting you a tool for classification of model parameters, which is also a case study. Let's start with motivation. As we all know, electronics is becoming more and more important in modern vehicles. The number of electronic control units is increasing and each of them need to be modeled. For that purpose, AutoSAR XML format is used and it needs to be parsed and adapted to specific code generators. Main reason for this step is optimization, where instead of very demanding parsing of XML3, specific program objects are used for each generator. The downside of this approach is system load on CPU and memory during the adaptation process. Next up is related work and implementations. Some implementers use already existing tools like MATLAB, TargetLink, and DaVinci Developer. Others use their own tools and toolchains. The tool in this presentation is based on an existing XCP generator used for calibration, which is written in Python and using Pickle serialization module. On the actual solution workflow, this paper had 4 key points that need to be followed. The generator should be based on existing XCP generator. The serialized model should be migrated to do SQL database. The whole generator should be translated to C++ language. And as it can be seen on the vocals below, the ATL files for ECU calibration should be created. First step was the migrating model to SQL database. It consisted of defining the database structure and creating tables which were based on lists and classes of key value store entries. Those entries were in the hierarchy shown below, which is SVCs, a prototype element, and multiple sub-elements. Those sub-elements can be divided into composite and primitive types. The composite types include other sub-elements, but primitive types do not. Finally, the model parser was written for that database. Next up is creating the XCP generator. It was consisted of removing the MVC libraries, modifying the existing generator, and integrating the SQL database. After all that, it was translated into C++. It can be seen on this slide that the function diagrams and KVS creation diagrams of that generator, where structures and arrays contain other types, but primitive types just contain themselves. And next up is execution time and RAM usage. As it can be seen on this slide, the execution time of the C++ generators is significantly longer than those of Python generators. And the reason that is because of the differences in variables between Python and C++, the process of translation to C++. In the next slide, it can be seen that also the RAM is significantly, the RAM usage is significantly bigger than the Python generators for the same reasons. There was an attempt to lower this usage by using TXT files, but it was not significant. To conclude all this, the SQL database and model parser were created. The XCP generator was successfully implemented, and the generated ATL files were functional despite having double entries. But because of the significant memory load and execution time of the case study of this paper, this is not satisfied. Thank you for your attention.
I have a question regarding database.
Yes, please.
Which exactly type of database did you use, relational or NoSQL? And if you can tell name of database.
I was using SQLite relation database.
Okay, it is relational. Thank you.